In this video, I'm going to show you how to solve absolute value inequalities with negative numbers. Start with the example, the absolute value of x is less than negative 4. I like reading my inequality left to right, so I like having the variable on the left and then reading towards the right. On a previous video I made on solving absolute value inequalities, I reviewed the steps to solve absolute value inequalities. So I'll link that video right here as well as at the end of this video. So our steps, I'm just going to go over the first couple. First step is we want to isolate our absolute value. Next step is we want to check for negatives on one side of our inequality. We're going to stop here at step 2 because we're going to meet this condition where we've got a negative on one side of our inequality. We've got negative 4 on that right side. Let's look at the condition we have here. We have the absolute value of x is less than negative 4. We have less than. We know from our previous videos that less than as well as less than or equal to, that's an and statement. If we're to write our compound inequality, let's think about what's happening here, right? So we have the absolute value of x. Absolute value of any number is always going to be positive. Let's bring down that inequality. So we have a positive number is less than what we have this value here, negative 4. So our inequality is literally saying our positive value is less than our negative value, which we know is a false statement, right? Our positive value is not going to be less than our negative value. So if we have this condition, if we have our absolute value is less than or equal to our negative value, we have a false statement and we've got no solutions. So our first rule for negatives, if we have an and statement, all right, reading left to right, where our variable's on the left, or that's less than or equal to, we're going to have no solutions because we're going to have our positive value is less than our negative value. Let's look at our next inequality. The absolute value of y is greater than negative 3. So now we have greater than. We know that greater than or equal to are both or statements from our compound inequality. If you want to review compound inequality, you can check out the link for the video. It's going to appear at the end of this video. I want to illustrate what the solution for this is two different ways. So let's start by writing what the compound inequality is here using an or statement. So our compound inequality is going to be y is greater than negative 3 or y is less than positive 3. Let's graph this out. So I want negative 3 and I want an open circle at negative 3 and an open circle at positive 3. Let's graph y is greater than negative 3. So I'm going to shade all the values that are greater than negative 3 and y is less than 3. I'm going to shade all the values that are less than 3. So you notice we're shading all the values on our number line. So that may give you a clue as to what our solution is compared to our first example where we had no solutions. Now let's look at our inequality. Let's do this the second way. Absolute value of y is greater than negative 3. We know the absolute value of y is a positive number. That's greater than negative 3. So that's going to be a negative. And we know that for any value of y, a positive is going to be larger than a negative. This is a true statement. So our answer here is going to be all real numbers. And this is going to be our symbol for all real numbers. Basically an R with two vertical lines. And from our graph, you notice we shaded in all real numbers, all the numbers to the right of negative 3, all the numbers to the left of positive 3. So our second rule, checking for negatives, if we have an or statement that's greater than or equal to, reading from left to right, our solution is going to be all real numbers. All right, let's do a couple examples where we have absolute value inequalities with a negative value. So for number 1, we've got the absolute value of 2x plus 3 is greater than or equal to negative 9. And I like reading my inequality left to right. We've got our absolute value and our variable on the left side. We've got greater than or equal to, so this is going to be an or inequality, an or compound inequality. We know that everything here should be a positive value. This is a negative, and positive is greater than our negative, so this is going to be all real numbers as our answer. We'll just write out what the math looks like. So we've got 2x plus 3 is greater than or equal to negative 9, or 2x plus 3 is less than or equal to 9. Now let's solve this for x. Let's subtract 3 and 3. Subtract 3 and 3. You get 2x is greater than or equal to negative 12. 2x is less than or equal to 6. Divide by 2, divide by 2, divide by 2 and 2. we get x is greater than or equal to negative 6, or x is less than or equal to 3. Now if we graph this out, negative 6 here, close circle, 3 here, close circle. X is greater than negative 6, going to be all the values to the right. X is less than 3 are going to be all the values to the left. And we're shading over all the values on our number line. So again, our solution is going to be all real numbers here. All right, let's go on to example number 2. For number 2, we've got 12 is less than or equal to negative 2 times the absolute value of x plus 3. I like reading this again left to right, so I want to put this absolute value on the left side. So I want to put negative 2 times the absolute value of x plus 3, and then 12 on the right side. And I've got to flip this inequality, so it's opening towards the negative 2 times the absolute value of x plus 3. I want it to open in the same direction, so the negative 2 times the absolute value of x plus 3 is still greater than the 12. Now let's isolate that absolute value, so I want to divide by negative 2, divide by negative 2. So I get the absolute value of x plus 3 on the left. I get negative 6 on the right. Because I divided by a negative, I've got to flip the inequality again. Now we've got an AND statement reading left to right. So just a reminder, this absolute value is going to give us a positive answer, is less than or equal to negative 6, which is a negative value. Positive is never going to be less than or equal to a negative, so this is going to be a false statement. So we have no solutions here. All right, let's do one more example. Number 3, I've got the absolute value of x minus 4 divided by negative 2 is less than 3. So let's start by isolating that absolute value. I'm going to multiply by negative 2 and multiply by negative 2. Negative 2's cancel out. So we get the absolute value of x minus 4 and then negative 6 on the right. I'm going to flip that absolute value so it becomes greater than. Now we've got our positive value on the left. Absolute value of any number is positive, is greater than our negative, which is a true statement. So our answer here is going to be all real numbers. And again, our greater than is our or statement. All right, so this video was on solving absolute value inequalities with negative numbers. I hope this video helped you understand this concept a little bit more. If you like this video, leave a like, comment, and subscribe. And check out the link for the video that's coming up right now on solving absolute value inequalities. This is Nick from First Coast Math Clinic.